Okay, let's start it.
Okay, so please listen. So let's have some kind of mind map. Quadratic equation has this, or quadratic graph. Equation would be 1 is equal to 0. Quadratic graph has that form. We all know the graph gives a parabola which concave upward or downward depending on the value of a. Where's this young man? Absent?
Yeah.
All right. Which concaves upward or downward depending on the value of a. So far, through your investigation and observation, you've been able to see what happens if you can write this in the form of y equals a into x minus b, x minus q. That is, if you can factorize so that you have two linear factors, you are able to sketch with that. You've also been able to see that if you can write this in the form of, this is an extension of this anyway, if these two linear factors are the same, you've been able to sketch that as well. If you are able to write this quadratic in the form y equals a bracket x minus h all squared plus k, whether you are given directly or you have to write it yourself, we've been able to do that as well up until yesterday. What we are trying to do today is, if we do not want to be bothered by all this writing factorized form, writing completing the square form and all that, can we factorize directly like this? Can we, sketch directly with that form? Without writing in this form or this form, depending on if they are the same, and without writing. So basically there are two things we can do. We can either factorize in this form, or we can factorize, or we can write in this form. But without actually any of these two, by just looking at it. Remember, the main point is if we can get the x-intercept, the vertex, right? The y-intercept, you have done with your sketch. That's all. X-intercept, y-intercept, and the vertex. Those are the key features when sketching a parabola, isn't it? Can we also do the same without bothering ourselves by any of this? Please note that under this, we never talked about our x-intercepts. Here is where we talk about our x-intercept. Here, I ask you not to worry about that. We only focus on y-intercept and the axis of symmetry. Is that not? But here we talk about the x-intercept, the y-intercept, the axis of symmetry, the vertex, and all that. But here, x-intercept is excluded. In this case, what can we do? That brings us to the roots of the equation. We can apply the root of the equation. Actually, we don't need the root of the equation, but we can do this by finding the roots of the quadratic equation. So, I need everyone to just pay attention. Roots of ax squared plus bx plus c equals to 0. Let's consider the roots of this equation. From y equals ax squared plus bx plus c, from the general form, or should I say, let's consider an equation directly. In the graph, the root of this equation is determined by what? Talk to me. If y is equal to ax plus bx, like that, how do we determine the root of the equation from this graph?
Factorize it.
Did he
Wait,
listen
no,
to me?
x-intercept.
Does everybody get that? I need everyone to talk, not one person. And I need you to listen to the question before you talk. From the graph, from that parabola, how do we determine the root of this equation? The x-intercept, which is where it crosses the x-axis. From this, the root of ax squared plus bx plus c is equal to 0 are the x-intercept. And this root can be determined by the formula method if you don't want to plot the graph at all. Right? By quadratic formula, X is equal to what? How many are they? How many roots? Two. Based on this plus or minus, right? So let's our b squared minus 4ac be capital D, the discriminant. We'll talk about that much later. It means our roots, then the roots, which means the x-intercept. Are you with me? The root or the x-intercept. The root of the equation. Because there's a difference between, when I say root, I'm talking about the equation. When I say x-intercept, I'm talking about the graph. Am I making sense now? Depending on in which context am I using these terms. Okay? The root of ax squared plus bx plus c is equal to 0, which is the x-intercept of the graph of y equals ax squared plus bx plus c. Okay? These roots are now, first one, minus b plus root d. Do you agree? Over 2a. And the other one will be what? X equals to those are the two roots. So basically, if we look at the picture, we're trying to establish something. You don't need to bother yourself about this later. You only need to bother yourself with the final results. Okay? Basically, if we have a picture, say something like this, it could be maximum, it could be minimum, so it doesn't really matter. So I'm just going to make do with one. It means these 2 points are the x1 and x2. Do you agree? So I could call this x1 and x2. Do you agree? And our axis of symmetry is determined by what? Say that again?
x1 plus x2 divided by 2.
x1 plus x2 divided by 2. We have the roots. Let's see what the axis of symmetry is. And the axis of symmetry also enables us to get what? The
x value of the vertex.
so that listen to Ansin, yes?
X value of the vertex.
X value of the vertex, x coordinate of the vertex. Does that make sense? So let's try to find the x coordinate of the vertex. Okay? So this is the x coordinate of the vertex. So if the vertex is x is equal to a, then our a is x1 plus x2 divided by 2. That's the point. Okay? And at the same time, this vertex here will be a comma something. Let's say f of a. Right? You know what I mean by f of a? The y value. Okay? Given that our graph can be represented with f of x. Am I making sense, please?
Yes.
I'm trying not to rush this part too much because the result is easier. It's now trivial. Okay. So if you do this, so this part x, okay? So consider the sketch. Okay, now I can't sketch anymore. Too bad. The sketch shown. Okay, we will see that the axis of symmetry, okay, or the x coordinates of the vertex is what? x1 plus x2 divided by 2. We agree? Okay?
Yeah.
So, which means x at the vertex. So maybe I call that x subscript v. X at the vertex. Something like that. Just a notation because we have so many x's now. Alright? So these two will be added and divided by 2. Okay? So the x1 negative b plus root d divided by 2. Because it's plus, I don't need to put the other one in bracket. And this has minus. And I have to divide everything by 2, so I'm going to say this instead.
I think it was the 2a.
Oh, my bad. He's having a nap. Let him have his nap. He'll be alright. Understand? You need duvet? Which implies the x coordinate at the vertex we can add, right? When you add, you get minus b plus root d minus b minus root d, everything divided by 2a times 1 over 2. Yes?
Yeah.
So this gives minus 2b over 2a times 1 over 2. Yes? And that is what? Good. So which means at the vertex, our x coordinate at the vertex, which is the same as the equation of the axis of symmetry, can be determined by minus b over 2a. This is what we need.
Isn't it minus 2b on the top?
Simplify.
Oh, I'm sorry.
It's okay. Does it make sense? So by looking at the equation, you can determine the x coordinate at the vertex. And by solving the equation, you can determine the x-intercept. Does that make sense? All you have to do is minus b over 2. Here is one thing. I give you this curve. I tell you the equation of the vertex is this. Or I give you the equation of the curve, you can determine this. Then I tell you one of the roots is this. Do you need to solve the equation to get the other roots?
No.
What do you do? No? Ah. Okay, again, listen. Oh, equation of the axis of symmetry is x is equal to 4.
Oh, I know.
Okay? Then I say, oh, one of the roots of the equation is 1. What is the other root?
7.
7. How do you get that?
4 minus 1.
I can't hear you. I'm not sure if I can hear you. Yeah. No, you're not using any formula.
Isn't it 4 minus 1 then?
Thank you, Ada. That's what it's a symmetry. The gap here will be equal to the gap here. So if this is 4, the gap is 3. Then this has to be another 3. And this must be 7. So without solving the equation, if you have one of the roots, you can determine the other one. Do you understand that? So in case I give you a sketch, okay, I didn't give you the equation of the roots of the, I didn't give you the equation of the curve. I just give you, I put this as 1, and I said this is x is equal to 4. Find the other roots. This is how you figure it out. Because that is the whole point of being a symmetry. Am I making sense now?
Yeah.
Please write a little. So now I write a summary of what to observe. Again, this xv represents x coordinate at the vertex and also represents what? The equation x coordinate at the vertex and the equation of the axis of symmetry. Although I put it up there, so I put it here again. Okay, everyone, and I have your attention, after which you have all the time to do your activity. You can complete yesterday's activity also after you have completed today's activity, and I will see you next week. This is, at the end of this, we are done with every form of ways to sketch quadratic graphs. All right, so this is a summary. If you want to sketch this, find the x coordinate at the vertex, which doubles as the equation of the axis of symmetry by just substituting minus b over 2a. Of course, you have your a, b, c as the coefficients in the graph. Does that make sense? The second thing is you put the value of x into the function to get the corresponding value of y. So you have the coordinate at the vertex. Understand? So you state your y-intercept. Y-intercept is definitely this one standing, right? Because y-intercept is when x is 0. When x is 0, nothing remains except c. So c is automatically your y-intercept. So you state that. You state the intercept. There is a specific instruction in the worksheet I'm about to give you. The first instruction says, for each of the following, locate the turning point, which is the vertex, and state whether the turning point is a minimum or maximum. Shouldn't have left so much space. It's just locate the turning point. So turning point is the vertex. Okay, the space should be enough. And tell us if it is minimum or maximum. So I didn't ask for sketch in number 1. I just said find the vertex and tell us if the vertex represents minimum or maximum. The second part of the worksheet, so I left enough space today. This is for one question. Just 4 of them. There are a lot of them in your textbook, about 8 or 9. I just picked 4. For each of the following quadratics, state the axis of symmetry. That's the first part of this instruction. Find the coordinate of the vertex. That's like number 2 as well. Find the axis intercept. So this number 2, I will do this because that is what this question is about. This is just to locate. Or maybe we do the same for both. We do the big one for both of them. Then you have like less to do in your activity. You understand what I mean? Okay. Find the coordinates of that, then find the axis intercept. What does axis intercept mean? Never said x or y.
Both.
Both. Find the x-intercept, find the y-intercept. So we'll follow this instruction for the 2 questions. And hence, sketch the quadratic. So that's what this question is saying. This is not an equation that we can solve and get the roots. So I better change some stuff there. It's going to end up giving us decimal. I don't want to work with decimal. I want to work with a real number. So I'm going to change this to 2x squared, 6x, let's say 2x squared plus x minus 3, something like this. I will get a rational number here. Okay. So the first part, state the axis of symmetry. How do we state? So first thing you do, A is equal to 2, B is equal to 1, C is equal to negative 3. You agree? Okay. Axis of symmetry is what?
Negative 3 over 2.
X equals to.
Oh, x equals to.
I'll penalize you someday. X equals to. Right? So we substitute negative 1 over 2 times 2, isn't it?
Yeah.
So which is x is equal to negative 1 over 4. So that's our axis of symmetry. Understand? The next question, according to this, say find the coordinates of the vertex. What does this represent in the vertex? The x coordinate. Then we find the y coordinate. Okay? So put x into y. So y will be equal to 2 times negative 1 over 4. Please press the calculator to make it fast. Plus negative 1 over 4 minus 3. Tell me what that is. So the vertex is x negative 1 over 4, comma something. Speak louder if you are speaking.
Negative 25 over 8.
Negative 25 over 8. Confirm that, please. Confirm, please.
Yes.
Thank you. Okay. So this is the second part in the worksheet. I'm putting the numbers so you can trace them with question 2. For the third part, the question I have here says find the axis intercept. You can easily get the y-intercept. What is the y-intercept, everyone? Speak louder, please.
Y equals minus 3.
Y equals minus 3. Just the guy standing alone. You don't need to say put x is equal to 0. No. And x-intercept. So for x-intercept, you don't need to write for x-intercept. But this is me explaining. Put y is equal to 0, isn't it? So for x-intercept, we are solving 2x squared plus x minus 3 is equal to 0. And solve by factorization or by formula method, your choice. So I will use factorization. I get minus 2x plus 3x. You can use the quadratic formula. Okay? So 2x bracket x minus 1 plus 3 bracket x minus 1 equals to 0. X minus 1, 2x plus 3 is equal to 0. So x is equal to 1 or x is equal to negative 3 over 2. Agree? So these are the x-intercept. The last thing says sketch the quadratic. So sketch, here we go. Normally, I would draw before I put this axis. So I know if it is too much or less, something like that. But let's try this first. So our x-intercept, one is positive and one is negative. You don't need to measure to scale, please. Don't waste your time. One is negative and one is positive. I think the first thing should be the axis-intercept, so you can make it symmetry about that. Perhaps I shouldn't put this yet. Let's just locate the x-axis. Okay? Axis of this is negative 1 over 4, so if this comes like that, negative 1 over 4. So the roots must be the same on both sides because it's axis of symmetry. Understand? So something like that. Now, is it going to be a minimum or maximum? Minimum, maximum.
Minimum.
Okay, you change your mind because why? You trust him? I don't trust him. Are you sure? It's not maximum?
Minimum.
Jensen, why is it minimum? Speak louder and fast, please. Why do you think it's minimum? Ryan, why do you think it's minimum?
I'm not sure.
You're not sure, King? Sure.
Because
Yanko?
A is positive.
That's it. A is positive.
Isn't negative.
A is positive. That's the only thing. So it's minimum. Okay? So definitely you have something like this. Okay? Now to put the y-axis, the y-intercept is -3. So it crosses at -3. Remember, this is y is equal to 0. Right? So y is -3 is below this red line. So negative. If this is -3/2. That's like 1.5. Crosses at -3. Wait. This is -1.5. -3 should be after -1.5.
X would be
Y is
0.
-3.
Y is -3.
Sorry. So this is y is equal to 0. So y is -3.